Okay, so I'm going to show you how to use verilogTown, and where you're going to start is on the web page because this is the place you're going to download it. So let's click download. Here's where the game files are. You can go there, it's on our GitHub, you can download it. It's a zip file which you'll have to unzip. Once you do that, you got to make sure you have the JVM 1.7 or higher installed, and it'll run on Windows, Linux, or Mac. So I've already downloaded, so let's start up the game. So on a Windows machine, I can click the the batch file, or I could go right and directly start the jar file. So I'm going to start the batch file. And here's the screen you're first going to see. And let's start the tutorial, which is actually a level 0, just getting started. And this is what you'll see. You'll see an intersection, one intersection, some information on how to start it, which I'm going to describe here. Press H for help, which will give you all the key mappings. So S will start the simulation, and that means cars will start entering the map and the traffic lights will be controlled. X will pause the simulation. M would go back to the main menu. R would restart the level. There's some buttons for zooming and moving around, and then the H key, which brings up and gets rid of that. So let's press S, start a simulation. Timer starts and cars start appearing, and then they respect the traffic lights. So right now all the traffic lights are just always on go. And it finishes. So there was one crash there, so 2 cars were unsuccessful and 10 cars passed, and it took 12 seconds. So your goal is to have no failed cars and minimize the amount of time it takes for all the cars to get through. So let's go look at how you would do that, and that's controlling the Verilog here. So I click on this intersection, and then this is the Verilog code that corresponds to that intersection. And now I'm not going to go into the Verilog and how Verilog works. On the website, if you click the Verilog tutorial, there's a lot of details. In particular, you can learn about a combinational template which we provide, as well as a sequential template we provide. And we go into details what each of the lines of codes does. But that's not what this is for. This is just how to play the game. So how to play the game. And so this is the Verilog that corresponds to this intersection. It's going to control it and allow cars to go or not go. The top part of this is a template that's set and has to be, you can't really change it because the simulator needs to know. And that is all this code right here. Okay, all the way to the end of the parameter. The parameters define what, so stop corresponds to the red, go will be the go anyway, forward only means the car would have to move only forward, left only, or right only. And we'll play around with those in a second. So this is a small piece of code, so let's load up the combinational template. And that loads all of this, and let's watch this one run. So I save it, I check if it compiles fine, I close it, and I simulate. So now instead of all go, we're going to see that when cars get there, the traffic light starts behaving and doesn't allow anybody to just go wherever they want. Still a car crash. Okay, so let's restart that. So let's look a little bit more into what's happening there. And let's go down to this first if line. And basically what this says, if there's no cars in an intersection. So how do I know that? Well, here's how the indexes in an intersection relate. So I know that if a car is coming, if a car's in the intersection, it'll turn on the sensor light 0, 1, 2, or 3. And so what this says is if sensor light 0 is equal to 0, as in there's no car there, sensor light 1 is equal to 0, and so on, then do the following. If there is a car in the intersection, then set all the lights to stop. So let that car basically get through the intersection. Now, if there is no cars in the intersection, and there is a car waiting at sensor light 6, which is the northbound car, then turn the northbound light on and keep the other ones at stop. And then that's basically done for all the different lights. So, well, we can do some simulations right here. So if, and this represents the sensor lights we just talked about, if I turn this one, the last bit, onto 1, what that means is we're simulating that a car is right here. So when we press simulate, I haven't compiled it yet, so we compile. When I press simulate, we'll notice that all the lights are stop, right? A 0 corresponds to stop. So that makes sense. If I turn all these off, and maybe I put a car at going northbound, and I simulate, well, I see the northbound light goes to go, which is 4. And that's this one right here. So let's change that, and let's actually make it go left only, for example. So left only. I save that, I recompile it, and then I simulate it, and now there's a 2 appearing there, and the 2 means left only. So right there. So I've made a change to the Verilog. Maybe that'll help me solve the level. So I close this down, and then I start simulating again. And what we're expecting to see is all the cars that come this way are going to go left only. So those guys go through, left, 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 left. So they all go left. No one crashes, but I still have a failure rate of 2 because 2 cars went to where they didn't want to go. They actually wanted to leave out this way. So I didn't get a perfect level, and I would try again and continue to modify my code. Just let me show you a few other things in the simulator editor. There's also a sequential template, so I could load that up and save it. Check if it compiles. Yes, it compiles. So in this case, you'll notice that the light moves around. So I shouldn't have any crashes here. This should be safe, but it'll be slow. So a few cars go, go, go. So we got perfect number. It took 16 seconds. So your challenge is you can get perfect, but can you improve on that time? So let's look at some other levels. Level 1, instead of 1 intersection, there's now 2. Level 2, there's now 3 intersections. And level 3, there's actually 11 intersections. Let's just watch this run. And these are all combinational templates. And we're going to have a crash right around here. Here it comes. A few more cars. So there's the crash. So your goal is to try and remove that crash and do it in the minimum amount of time. If you do that, you can send us your Verilog code and you will get your name on the leaderboard. So for example, the current leader on level 3 is Jeff Eaton on June 25th, and he completed it perfectly in 17 seconds. So you could get your name on that leaderboard. A few other things on the website you might want to know. There are some bugs, so we have bug reporting. These are the people who helped design it. Here's how to download it. We saw that there's a how to play it in written form, the Verilog tutorial. The game simulator tells you some ideas about the game simulator and how it behaves. That'll help you figure out how to take advantage of the Verilog and control the cars. There's some existing solutions if you want to see some different stuff. So for example, we have a finite state machine Verilog solution here. If you want to see some other examples. Verilog help, there's 2 of the rules that I have that I give to my students for synthesizable Verilog. This tells you what's actually supported in verilogTown. We don't support all of Verilog, just a small synthesizable subset of the language. And then there's some other Verilog resources if you get interested in the topic and you want to go deeper. So that's a basic how to play verilogTown. Hope you enjoy.